Okay, today's lesson is going to be covering solving inequalities. So, here are the inequality signs that we need to be familiar with. The first one is less than. Notice that it kind of looks like a slanted L. So, if you have difficulty remembering these, that's one way you can do it. The next one is greater than. We have less than or equal to, and we also have greater than or equal to. So just like for solving equations, we are going to be utilizing inverse operations. So the process is very similar as solving equations. The only real difference is that if you multiply or divide by a negative number, you're going to have to reverse the inequality sign. What I mean is if it's less than, make it greater than. If it's greater than or equal to, make it less than or equal to. So you're literally just going to flip that sign around. And here's why. So if we start with a true statement, 2 is less than 6. That's true. 2 is less than 6. We know that we should be able to multiply both sides and get another true statement. That's by the multiplicative property. But if we take a look, if we multiply by -3 on both sides, 2 times -3 gives us -6, and 6 times -3 gives us -18. -6 is not less than -18. So again, we have to flip that sign around so it does make a true sentence. -6 is greater than -18. Now it's true. So that's why you have to reverse the sign when you multiply or divide by a negative. We are going to be also graphing some inequalities on the number line today. So these are just some properties to keep in mind as we graph them. If we have a less than symbol, we are going to shade anything on the number line that falls to the left of that number. So left is always less. The type of dot that we would use is an open dot, meaning that you can get very, very close to a particular value, but you don't want it to equal that number. Greater than, we're going to shade anything to the right on the number line, and again, that's an open dot. For less than or equal to, left is always less. We're going to shade to the left again, but because we can get equal to the number, we want a closed dot, meaning we fill in the circle. It could be that number. And then greater than or equal to is shaded right, and again, a closed circle. If we have an open circle, an open dot, and we want to write the inequality in what's called interval notation, we would use a parenthesis anytime we have an open dot. If we have a closed dot, we are going to have one parenthesis and one bracket. The bracket goes with the number that you want to include in your data set or solution set. All right, so let's go ahead and take a look at our first example. We're going to first solve it. Then we're going to graph the inequality, and then we're going to take a look at, well, what would that equality look like in interval notation? So the first step here, we're going to use inverse operations. We see -2 times x plus 8 is greater than 12. So I want to get rid of this plus 8 as my first step. So we're going to subtract 8 from both sides of that inequality. +8 minus 8, that makes 0, so those cancel out. And 12 minus 8, that gives us 4. If I bring down anything that we haven't used, we have -2x, and we have that greater than symbol. So we have -2x is greater than 4. We want to get rid of that -2 that's being multiplied by x, so we're going to divide by -2. So we get x. Now we divided by a negative, so we have to switch that sign around to less than, and 4 divided by -2 would give us -2. So that is our solution to that inequality. X has to be less than -2. Thinking about graphing that, I want to think about the numbers that are less than -2. Remember, left is always less. So if I look at where -2 is on the number line, anything to the left of that is a negative value that is less than -2. But I do not want to include the value of -2 exactly. So maybe I want to say -2.1 because that is less than -2, but I don't actually want to include -2. So I am going to put an open dot at -2, meaning I can get very, very close to it, but I don't want to actually pick -2 as a solution. And I want to shade anything that's to the left. Left is always less. So my possible values, -3, -5, -10, -1,000,000. Those are all values that are less than -2. The last thing that we need to be able to do is to write this inequality in interval notation. So we always read from left to right. So if I'm looking on the left side of this number line, notice that there's an arrow. So that's going to continue on forever in the negative direction. So I'm going to say that my smallest value is -infinity. And if I go all the way to the right, again, we're getting really, really close to -2. Even though I don't want to include -2, I'm going to put the -2 there, but then the parenthesis actually means that I can get really, really close to it, but I'll never actually reach that value. Anytime you use a negative infinity or an infinity symbol, it always has a parenthesis because you can't ever really reach infinity or negative infinity. It's not really a number, it just means it continues on forever. Okay, so that was our first example. All right, our next example looks like 2/3 x minus 10 is less than or equal to -9. Again, we're going to be using inverse operations to solve this. So the first thing we want to get rid of is the -10. So we're going to add 10 to both sides of the inequality. If we simplify that, -10 plus 10 makes 0, so those cancel out. -9 plus 10, that gives me +1. And if we bring everything else down, we have 2/3 x is less than or equal to 1. We have that fraction in front of x that we want to get rid of, so 2/3 times x. Here, although the opposite operation is divide, it's going to be easier if we multiply by the reciprocal. So remember, anytime you see a multiplication sign or a division sign, you could think multiply by the reciprocal. So we're going to multiply both sides by the reciprocal of 2/3, which would be 3 halves. All right, so we're going to simplify that left side. 3 halves times 2/3. That makes 1. They're inverses, so we just get 1x, or just 1, is less than or equal to, and then I'm going to put that 1 over 1, so then we can just multiply straight across. 1 times 3 is 3. 1 times 2 is 2. So I have the inequality. X is less than or equal to 3 halves. Now, notice we did not reverse the inequality on that one because we did not multiply or divide by a negative value. We multiplied by a positive value. So we do not reverse the sign if we multiply by a positive value. Okay, so if I think about what 3 halves means as a decimal, 3 halves is 1.5. So I need to locate 1.5 on my number line. It is less than or equal to 3 halves, so I do want to include that 1.5 in my solution. So I'm not going to draw an open dot. I'm going to draw a closed dot, which means I fill it in. That's hard to do on this screen, but hopefully that looks like a filled in dot to you guys. All right, we want anything that is less than or equal to 3/2. Left is always less, so I'm gonna shade to the left. Again, I could pick possible solutions. 0 would be in my solution set. Anything negative would be in my solution set. And 1.5 is in the solution set this time, or 3/2 is in the solution set this time. If I write that in interval notation, again, I'm going to read from left to right. On the left side, notice the arrow, so it's going to keep going down. So negative infinity, again, is my smallest value. And then on the right side, I have that 1.5 or 3/2. This time, I want to include the 3/2. So we use a bracket to indicate that we want to include that number. And then again, anytime we have an infinity symbol or a negative infinity symbol, we use the parenthesis. All right, the next example that we have on here is -5 times the quantity x plus 3 is greater than or equal to 7x plus 4. So first step, we're going to distribute that -5 through. So -5 times x is -5x. -5 times 3 is -15. Is greater than or equal to 7x plus 4. I need to gather all of those x's on one side and all of the plain numbers on the opposite side. So I'm going to move that positive 7x over to the left. So to get rid of it, I need to subtract 7x from both sides. Here I would get -12x. I'm going to pull down the -15 is greater than or equal to 7x minus 7x is 0, so those cancel, and we just have the 4 left over on the right. Right, I see -15, so I'm going to add 15 to both sides. So here I get -12x is greater than or equal to 19. Last step, I need to get rid of that -12 that's being multiplied by x. So I'm going to divide both sides by -12. Okay, I divided by a negative value, so I need to make sure I'm reversing that sign. So it's not greater than or equal to anymore, it's less than or equal to. And 19 divided by 12, those do not divide evenly. So I am just going to leave that in improper form. So -19/12. Okay, so thinking about what that number would mean on the number line, 12 goes into 19 once with a remainder of 7. So I'd have -1 and 7/12. So that's awfully close to -1.5. So I'm just going to find approximately where -1.5 would be on the number line. This one is less than or equal to, so I do want to include that -1.5. So I'm going to fill in a closed dot at approximately -1.5, -1 and 7/12. And again, it's to the left. Left is always less. Interval notation for this one, if we move from left to right, -infinity is the smallest value on the left. It goes up to that -19/12. And I do want to include that 19/12. So I'm going to put a bracket on that one, and then those infinity symbols always get the parenthesis. Okay, the last example that we're going to go through together is 7 minus the quantity 2x minus 12 is greater than 5x plus 6. So taking a look at this one, in order to get rid of those parentheses, I need to distribute that negative through. So I can think about that as being a -1 that I'm distributing through. So -1 times the 2x and -1 times the -12. So -1 times 2x is -2x. And -1 times -12 gives me +12. I'm going to bring down anything that we haven't used so far. So 7 minus 2x plus 12 is greater than 5x plus 6. All right, I see some like terms that we can simplify. Here we have 7, +7, and we have +12, both on the left side. So I'm going to go ahead and combine those like terms. 7 plus 12 gives me 19. I'm going to bring down the -2x plus 19 is greater than 5x plus 6. We have variables on both sides of the equation, so let's gather those on one side and the plain numbers to the opposite side. So I want to move this +5x to the left side, so I'm going to subtract 5x from both sides. So we would get -7x plus 19 is greater than 6 because 5x minus 5x is 0. The next thing I see is +19, so I'm going to subtract 19 from both sides. So here we would get -7x. 19 minus 19 is 0, so those cancel, is greater than, and then 6 minus 19 gives me -13. Last step, we're going to divide both sides by that -7 that's being multiplied by x. So I divided by a negative number, so I have to remember to flip that inequality sign. So we have x is less than 13 over 7. Negative divided by a negative makes a positive, so I got rid of those negative signs. 13/7. Okay, 13/7 goes almost 2 times, right? It's 1 6/7. So 1 6/7 is going to be very close to 2 on the number line. So here I have to think open or closed. The inequality says x is less than 13/7, so I do not want to include that. So I'm going to put an open dot very, very close to 2. It looks like it's on 2, but it's very, very close to 2. And then again, we have a less than symbol, so shaded to the left. Left is always less. In interval notation, again, I'm going to read that from left to right. So it's -infinity to 13/7, very close to 2, but we're not including that number. So that's going to be a parenthesis on both sides because the infinity symbols always get the parenthesis. Okay, it is time for the U-try. I did not have enough room on here, guys, to put the graphs and the interval notation. So please solve these, graph them, write the interval notation for them, and then unpause the video, and we will take a look at those in just a moment. All right, everybody, hopefully you've had enough time to take a look at those. Sorry, I had to kind of write all over the screen, but for number 1, we're solving it here, and we get x is less than -2. So we'd have an open dot at -2 shaded to the left. The interval notation would be from -infinity to -2, parentheses on both of those. Part B, solving it, we had to distribute the 1/2 through, and then we get here, x is greater than or equal to -15/4. -15/4 is really close to -4, almost -4. So it'd be -3 1/4. So, or I'm sorry, -3 3/4. So closed dot close to -4, and it's shaded to the right because greater than or equal to shades to the right. Interval notation, we want to include that -15/4. So there's a bracket on -15/4 to infinity and parenthesis on that infinity. So -15/4 is the smallest value we have, and we go up from there. So remember, always write those from left to right. Okay, part C, we solved that inequality. I did my opposite operations here first and then jumped over here. And we get y is greater than -2. So open dot at -2, again shaded to the right. Our interval notation is from -2 to infinity, parentheses on both. And then the last one, part D, we have, I solved it here. There was two combining like terms. We had to combine the -4x and 2x, and we had to combine the +6 and +12. I did that both in one step, so hopefully everybody's okay with that. We get x is greater than 1/2. Interval notation is here, parenthesis 1/2, comma, infinity, parentheses on both. And we have an open dot at 1/2, again shaded to the right because it is greater than. Okay, this concludes the notes on solving inequalities.